हरि करना।
So, in probability theory, a probability distribution is a function that describes the likelihood of observing different outcomes in a random experiment or process. The distribution can be either discrete or continuous depending on whether the possible outcomes are countable or uncountable respectively. So we have a lot of different types of probability distributions, a lot of examples for that, from binomial normal distribution, Poisson distribution, exponential distribution, uniform distribution, and gamma distribution, beta distribution. And these are just a few examples of probability distributions, and there are many others. So understanding the properties and applications of different probability distributions can help us choose the appropriate distribution for our data and build more accurate statistical models. So let's begin with our first concept under this, probability of large numbers. Probability of large numbers. So in probability theory, large the law of large numbers, we call it as a law of large numbers. Law of large numbers states that as the number of trials or observations increases, the average or mean of the observed values will converge to the expected value of the underlying distribution. In other words, as we collect more data, the observed values will become more representative of the true population. So this is what we call it as a law of large numbers. So law of large number is a fundamental theorem in probability theory that describes the behavior of the sample mean of a random variable as the number of independent samples increases. It states that as the number of trials or sample size increases, the sample mean will approach the true mean of the population with increasing accuracy. So in other words, as the sample size increases, the variability of the sample mean decreases. As the sample size increases, the variability of the sample mean decreases. I think you might have heard this kind of a similar theorem somewhere, the central limit theorem. As the sample size increases, it approaches the normal distribution. So here, as the sample size increases, the variability of the sample mean decreases, and the sample mean will approach the true mean of the population with increasing accuracy, because as the accuracy is increasing means your variability is decreasing, and the sample mean will become closer and closer to the expected value of the random variable. So now let's take a few examples for the law of large numbers. So we'll put it as a law of large numbers. Law of large numbers is nothing but as the sample size, as the number of trials, let me put it in this way, number of trials or observations or sample size increases, the mean of the observed values will converge to the expected value of the underlying distribution. Okay, this is what we call it as a law of large numbers. So let's look into the first example, that's coin flipping. Suppose we flip a fair coin many times and record the number of times it comes up head. So flip a coin many times and record number of times it comes up head. It comes up head. So as we flip the coin more and more and more times, as we flip a coin more and more times, the proportion the proportion of heads to total flips will converge to the expected value of 0.5. So according to the law of large numbers, Then let's look into the second example, that's dice rolling. We suppose we roll a fair six-sided die many times and record the average of the numbers rolled. As we roll the die more times, as we roll the die many times or more and more times, the proportion of heads to total flips will converge to the expected value of 0.5 according to the law of large numbers. Then we have stock prices. So the third example, stock prices. Suppose we observe the daily returns. Observe daily returns of a stock over a long period of time. According to the law of large numbers, the average daily return will converge to the expected value of the stock's overall rate of return. Similarly, opinion polls, very important. Opinion polls. Now the elections are going on. Suppose we conduct a poll of a large number of people. Suppose we conduct a poll of a large number of people and record their opinions on a certain issue. As the sample size increases, the proportion of people with a certain opinion will converge to the proportion of the entire population with that opinion. So in summary, the law of large numbers is a fundamental concept in probability theory that explains how observed values converge to the expected values as the number of trials or observations increases. This concept has many applications in fields such as finance, statistics, and public opinion research.